First, we will discuss about uniform circular motion. That implies speed remain constant. Now, speed, that is magnitude of the velocity, remain constant. Okay. Now, in circular motion, a particle rotates around the circular path. Okay, with uniform speed. That means magnitude remain constant. Okay, uniform speed. Now, we know that the relation between arc and the angle subtended by the arc at the center. Suppose the center and the radius, and it makes theta degree radian, that is theta radian C, that is circular measure at the center. If it is R and S be the length of the arc, therefore relation among S, theta and R is equal to S is equal to R theta. Okay. Now, for a greater radius, when R is much greater than S, this S become a straight line. That is, when this line, if this angle become very small, we can treat this part as straight line. Suppose this is del theta, and this is del S, and R remain same. So we can say that del S is equal to R into del theta. Okay. Now, direction of del S along the tangent at this point, that is perpendicular to this, and direction of R is along this. So, this is R cap and this is del S cap. That is unit vector along this. Now, it is clear ds is vector, R is vector, and also d theta, del theta is also vector. So, this is possible only when two vectors are, product of this vector is by cross product. Cross products results a vector. So, ds is vector, R is vector, and S is vector. Now, what will be the direction of the del theta? What is the direction of the angle? Now, if it is considering this is I direction and this is J direction, so when we get J and this is I, so it must be K. Clear? In cross product, result will be perpendicular to both the vectors. The perpendicular to the R perpendicular to the theta. So J is perpendicular to I and also perpendicular to K. So we can say that K cross I is equal to J. Therefore, direction of theta comes first and direction of R then second. So we can say that del S is equal to del theta cross R. Clear? So theta will come first because it is in K direction. It is in I direction. K cross I is equal to J. Theta will come first and then R. Order, in case of cross multiplication, order of the very important part because it is not commutative. Okay. Now, if this del S distance covered in del t time del theta divided by del t cross R, so we can say that V, this is tangential velocity, is equal to omega cross R. Okay. Omega del theta del t is equal to omega angular speed and this is a vector quantity and this is called axial vector. Why axial vector? Because direction of this angle along the axis, because the plane in which angle belongs, theta is perpendicular to that plane. Okay?
Theta is perpendicular
to that plane. So along the axis of the circle. Okay? If it is this is circle and center, then direction of the is along this direction. R along this direction and S is along this direction. This is I, this is J, and this is K. You can derive it by this method. S is equal to R theta, ds dt is equal to R d theta dt, and this is Vt is equal to omega cross R, omega into R, and finally you have to give reason why Vt can be written as Vt is equal to omega cross R. Del S del t, limit del t tends to 0, del S del t is equal to ds dt. That means in the case of dt, it confirms ds is very, very small. Okay, and del S it may have greater magnitude. Okay. Suppose at t is equal to 0, particle is at this point, and when after a small time interval del t, it reaches at this point. This is del theta t is equal to del t. Now, at this point, its direction of velocity along the tangent, that is perpendicular to this line, and at this point, it's also perpendicular to this line. Now, if we take this vector and this vector, then magnitude of these two vectors are same because both are velocity vector. Its magnitude remain constant. So, their length of the line remain same. This is the length magnitude of the vector, and this angle is equal to del theta. Okay, del theta. Now, change of this is v1 vector and this is v2 vector, that is velocity vector v1 and v2. Now, magnitude of v1 is equal to magnitude of v2 and this is equal to v, say. So, we can say that this triangle is isosceles triangle, and from vector triangle we can say that this will be v2 minus v1, this length, this is the magnitude of the vector. Since these two sides are equal and this is del theta, very small angle, so each angle will be 90 minus del theta by 2. Clear? Now, using Lami's theorem, we can say that magnitude of v2 minus v1 by sine of angle of its opposite angles del theta is equal to magnitude of v1 divided by opposite sine of opposite angle. Okay. Now, this may be written as del v, that means change of velocity, and this is 2 sine del theta by 2 cos del theta by 2. And this is v, that is this is the magnitude of the change of velocity, v by, and this is magnitude of the velocity cos del theta by 2. This will be cancelled since del theta is very small angle, therefore sine del theta by 2 tends to del theta by 2. So, we can write it del v by 2 del theta by 2 is equal to v. So, del v is equal to v into del theta. So del V divided by del T is equal to V remain constant, so del theta by 2. Okay. This acceleration is called radial acceleration, is equal to V into omega, or is equal to V is equal to omega into R, so omega square into R. Now the direction of the acceleration. It is clear that this change of velocity makes 90 degree minus theta by 2, since del theta tends to 0. So we can say that this angle 90 degree, since this angle is 90 degree minus del theta by 2 and theta del theta tends to 0, so we can say that 90 minus del theta by 2 is equal to 90 degree. Therefore, this change of velocity makes 90 degree with the direction of the initial velocity. That means 90 degree of initial velocity, that means in this direction.
Acha.
In this direction. Okay. Therefore, we can say that direction of the acceleration is along center to the circle. Okay. So we can write this in vector notation is equal to omega square R minus along radius but opposite towards the center. So it is minus. This is called centripetal acceleration. Okay. Therefore, centripetal force, that is force required for this acceleration, is equal to m into AR, radial acceleration, is equal to minus m omega square R, or m v square by R with R cap. These are the expression. Okay. This is called centripetal
Acceleration.
Centripetal force. Okay. So the role of centripetal force is only to change the direction of the motion. It never contributes any part to the magnitude of the motion. This is very important. Centripetal force or central force. Sometimes it is called central force, required to change the direction only. Only it can change the direction of the motion. Okay? Now, application of this. Since in a body rotating in circular reference frame, that is the reference frame which rotates in a circular path. So there should be a centripetal acceleration. In case of circular reference frame, there is an acceleration. Along the center. So it is no inertial reference frame. So in case of non-inertial reference frame, there must be a pseudo force acts opposite to the pseudo force acts opposite to acceleration of the reference frame. So if acceleration of the reference frame along the radial direction of the pseudo force away from the center, and that force is called centrifugal force. Centrifugal force is equal to then m omega square r along. Here it is minus m omega square r in case of centripetal force, and for pseudo force this is m omega square r. Clear? Now, when a car moving in a circular path, suppose a car is moving along this circular path, so passengers of the car are in a non-inertial reference frame whose acceleration is along this direction. So at every point, passengers experience this force, which is centrifugal force, that is due to the non-inertial reference frame. This is centrifugal force. Now, the whole car experiences a force just opposite to this direction. Okay? If there is no friction, then car will skid away from the center. So the maximum velocity by which it can turn will be, that is m omega square mv square r. It is better to express by v because we can measure the velocity. M velocity of the car by its odometer, mv square by r is equal to frictional force. Friction between road and tire. is equal to mu into mg. So speed should be less than or equal to, m will be cancelled, mu or g, v less than or equal to root over mu or g. Limiting speed that the car can maintain. Now, in case of turning in a highway, when cars are moving with a very high speed, roads are inclined to the center of the circular path. This inclination is called banking. This is the cross section of the road, and road is like this. This is cross section of the road, inclined towards the radius. Suppose this is a car. When it moves around the circle, it experiences a horizontal centrifugal force because a non-inertial reference frame have a acceleration towards the center. So this will be the, and this is equal to mv square by r. Okay. If this banking angle be theta, now we know that if we resolute its weight along the direction of the incline and perpendicular to the direction of the incline, and also we resolute the centrifugal force along the direction of the incline, and perpendicular to the direction of the incline. Now it is clear this angle will be theta, this angle will be theta. So if it is mg, then it will be mg cos theta. This is mg sin theta, and mv square by r, this will be mv square by r cos theta, and this will be mv square by r sin theta, and this will be normal reaction n. Now, first, for smooth plane, smooth road, that is, there is no friction, what will happen? This should be balanced by this. Mg sin theta should be equal to mv square by r cos theta. So tan theta is equal to v square by rg. Okay. For a rough surface, that is mu not equal to 0, in that case, frictional force is equal to mu into n, that is equal to mu into N balances the two forces mv square by r sin theta and mg sin cos theta. So n should be equal to sum of these two. That is mv square by r sin theta plus mg cos theta. And frictional force acts in this direction against the skidding action, that means in this direction. So friction force will help not to skid the car, so it will act in downward direction, that is along the direction of the mg sin theta. So mg sin theta plus mu into mv square by r sin theta plus mg cos theta, the total force along this direction, and that must be greater than or equal to mv square by r cos theta. Okay. Now cancelling m, we get g sin theta plus mu into v square by r sin theta plus mu into g cos theta greater than or equal to v square by r cos theta. We have to find the maximum velocity, so this will be g into sin theta plus mu cos theta greater than or equal to v square by r cos theta minus mu sin theta. Now mu can be written as tan phi, where phi is equal to angle of friction or angle of repose. Therefore, g into sin theta plus tan phi, that is sin phi by cos phi into cos theta greater than or equal to v square by r cos theta minus sin phi by cos phi into sin theta. That implies g sin theta cos phi cos theta sin phi, sin theta cos phi plus cos theta sin phi divided by cos phi is greater than or equal to v square by r cos theta cos phi minus sin theta sin phi divided by cos phi. That implies g sin theta plus phi v square by r cos theta plus phi. So tan theta by phi greater than or equal to v square by rg. Okay, and the maximum speed v less than or equal to tan theta plus phi rg root over. This is for joint entrance purpose with friction, without friction for board purpose. Now, in case of two-wheeler or bicycle, when they turn around a circular path, they inclined with the road. That is also self-banking. Suppose this is a road, a cyclist moving in this direction, he should incline with the vertical direction. Suppose this is CG and its weight acts along this direction. Mg, and centrifugal force acting this direction. The m v square by r. And what is the angle between these two? Actually, resultant of these two should be reaction of this, and reaction acts along this direction, because if it acts other direction, then cycle will topple. Okay, this is the reaction. Okay, so r cos theta should be equal to mg, and r sin theta should be equal to mv square by r. R sin theta is equal to mv square by r, and r cos theta is equal to mg. So tan theta is equal to v square by rg. Same expression. Clear? But this angle is with vertical, and that in case of banking, this angle is with the horizontal. This is the difference.